class we had, we stopped at START-PROF, this particular segment, and this model we are told that we can model this using START-PROF. And on this slide, we have the design of six object types, which include systems, the support, displacement, and deformation. So from this our slide here, we can see the pipe that has been modeled already, all these fixtures in them. So I'm going to zoom this now. At this part, you observe that you have an anchor. Now, what's an anchor? Anchor is simply a device that is used in holding or keeping objects in place. So any device used in holding or keeping objects in place is referred to as anchor. So this modeling is in our practical section using START-PROF. So get to the next slide. All right. For this, now we have the Cartesian system. Now this Cartesian system helps you to coordinate the X, Y, and Z coordinates for your three-dimensional drawings. Remember, for three-dimensional drawings, you must have the X coordinate, the Y coordinate, and the Z coordinate, which gives you the direction in which your drawing or your modeling will be going to. Okay, so we have here the best type of projection, that's the best type of piping here, which is the Z, X, and Y, as I've explained previously. So we'll get to the next slide now. All right, from here, we also see a model that's a section of the previous model. And from what we can see here that START-PROF will bring up for you. Now, this property here can be edited, although it's been calculated for us. So we don't need to stress ourselves much in that any dimension wants to change based on the properties given to you by the client person in which you are trying to model your. So here you have the dimensions which you can easily change. Okay, you can change the thickness of the pipe, the diameter of your pipe. You can model a particular tolerance. You can also use a particular temperature. That's the temperature in which the pipe will be conditioned during operation. So during the operation of the model, the pipe that has been modeled, it needs to undergo a particular amount of temperature. So if the temperature of the fluid or the substance in which you want to pass through the pipe that you have about is like 150 degrees Celsius, then you have to set it here during your piping modeling. And then remember that the test pressure and the test temperature should be greater than the normal temperature. Reason being that if there is any incident or if an incident occurs that an abnormal situation comes up, then your pipe will be able to also withstand that excess temperature or pressure. But if you model having a lower test temperature and pressure, then your model will be as though it's right. But in real life, when the pipe goes to a temperature or a pressure greater than the calculated pressure, then you see that your pipe will be deformed. That's why we need to take cognizance of the temperature and pressure we use during testing. Okay, so get to the next slide. Okay, here we have the piping restraints too. Here we have the standard support, the anchor, the hinge anchor, the sliding of the rigid anchor. From the right hand side here, you can see the non-standard restraints also, which gives you the properties of a non-standard restraint. Here you can also change your, okay? So we'll get to the next slide. Now here, you have your restraint type. Now your restraint type has to do with the type of restraints you can have. Remember, this restraint is talking about things that can help in keeping things in place. That's why we define anchor as a device that is used in keeping objects in place. Okay. So here we have the two-way, the one-way, the gap. That's the restraint type with gap. Now for the two-way support or the two-way restraint, it means that the pipe that you are modeling can move in two directions. So if you see here, you observe that the arrow here is showing you that the pipe that is being modeled can be moved in the upward or in the, that's either the upward, which is the vertical direction, or the horizontal direction. Whereas the one-way modeling can only go in one direction. So from the diagram we have here, the upward direction. Okay, so here we have the restraint with gap. Now, restraint with gap simply means a form of allowance that or tolerance that is given to your pipe. So with that tolerance space, the pipe can be moved within that constrained path. So you can't exceed the tolerance or this gap or allowance that is given to it. Okay. So in general, we call this restraint pipe with gap, we refer to it as allowance or tolerance, depending on what you are trying to model. Okay. Now we have here the linear rigid, the linear elastic, the rotation rigid, and then the rotational elastic. For the linear rigid, we observe that if a load is placed at the left-hand part of your, and it has a reference at the down here that the pipe was it will slide through a particular angle. Okay, whereas if having a linear elastic support, then when the load is placed at the center, then there tends to be a form of bend. That is the load is removed. That's to say, when the pipe is not in operation, the pipe will get back to its original position, and it becomes straight. Okay. Then for your rotational rigid, so rotational rigid has to do with a form of force that is rotational. That when you have the moment, just like your elementary physics, that's about moment of force. So when you have the moment of this particular pipe at a particular end, then you observe that the pipe tends to bend in one direction. But remember that once that moment or once that force or that load is removed from the pipe, then it has to get back to its original shape. Okay. Then for this, you have your rotational elastic talks about a form of rotation in which the support is a form of elastic, is elastic in nature. So this place, you see the slide here. It will be as that of just rotation rigid. Okay. And here you have the formula here that tells you that P is equal to 5 over n. Need much of this because it has been already built into START software. Okay. So here we have the anchor, which I've explained previously. Now, for the different types of anchor, just like you can see here, you have different types of anchors, just like you can see here. Then, in between these anchors, which we have, you have the properties too. That's all. These properties can be altered, they can be changed, they can other values can be put into them when the need arises. Okay. Now we have the hinge anchor. It's an anchor that is used also to keep your pipe in place. Okay. So look at the hinge anchor we have here. In your modeling, you should know that there is hinge anchor which you can use in keeping your object in place. So this is a ridge anchor. So this is the 2D of this, how your 2D of the ridge anchor looks like. Okay. Then here you see how START-PROF represents this. So this is how START-PROF represents the anchor. Okay. Whereas this talks about the properties which can be changed or altered or which you can also impute. All right, so talking about the sliding support. For your sliding support, we still have different supports are the things you can see here now. Look at your sliding support, look at different types of them, and look at also the properties that are also in START-PROF that you can impute your values or your parameters, the pipe that you're modeling needs. Okay, and this is also how this sliding support is presented in START-PROF. So it's presented in START-PROF. So whenever you have a sliding, this is how it will be represented in START-PROF. Remember, I told you that we have different types of sliding support. Okay. All right. Here we are looking at friction in operating and that's in operating and code state. When we talk about operating state, it talks about when this pipe has been modeled and is in operation. That is to say, the fluid, the liquid, the gas, or whatever you're trying to pass through this pipe, which could be crude, during its operation state, it means that that particular fluid that is to be passed through your model is already passing. So during operation state, it's in the state whereby the pipe is already carrying the fluid or transporting the fluid or the material from one point to another as required. Whereas the code it has to do with the state at which it's not in operation. Okay. Now here we have different calculations done here. Okay. They are all built into the software. So look at this place. If you look at this place carefully, you will see the installation state at ambient temperature, the operation state at design temperature, the code state at ambient temperature starts cooling down. So in this installation state at ambient temperature, talking about ambient temperature, we are looking at the temperature of the surrounding in which this particular pipe is the operated in. So the temperature of the surrounding, that's the environment in which this your pipe that we've modeled is to be operated on. At the installation state, that's the state in which you're installing this pipe now in life. This pipe that you modeled, in its installation state, the R will be equal to 0. That the reaction will be 0 and the force also will be 0 because that's the installation state. That's at point of installation. Then during operation state, the R will be greater than 0 if it's now in operation. And you see a formula here telling you that F will be equal to mu times W. Talking about the force being equal to coefficient of friction. That's the product of coefficient of friction and the weight of the load. That's the load that you are passing through the pipe. Then at code state, the code state here, it means that the load now is to be removed. That's to say, the of the pipe is no longer in operation. So when you finish transporting the product to its destination, and then you've shut down operation, at that point, we say that the pipe or the model will be in the code state, okay? And at that point, you have your relationship here, which shows you that R will be less than 0, and your force will remain at coefficient of friction times the weight. Okay. Now here you have also an illustration of what we just said now. This is the illustration of what I just explained now. Okay. The installation state, the operation state, and the code state. So this is the illustration. Okay. Now here we are looking at the rigid hanger now. For rigid hanger, just like we have our hangers at home, that's the hanger holding your fan. But this time around, we are talking about a hanger that is used in keeping your piping model in place. That's a hanger that is used in holding or keeping our piping model in place. So this is how a hanger looks like. And the next is here, which I've explained previously, that it can be altered. You can fix in the values or the properties in which the pipe that you're modeling will read to exhibit or have inbuilt in it so that the pipe can withstand all external forces during operation. Okay, these properties can be changed. Now, here we also on START-PROF. So whenever you see this representation using this your START-PROF, you should know that this is talking about what? The rigid hanger. So here we have the one-way guide support. Now, your one-way guide support is simply a guide that ties your piping system or your model in place so that it can only move in just one direction. So this guide now will help keep your pipe in place so that it can only move in one direction. Okay, the same thing that is down here. This is how that is being represented in START. Okay, this is how it's being represented. So if you see the arrow here, the arrow is showing you that this pipe can be moved in one direction. That is being guided by your support such that it can only move in one direction. Okay. Now you have the two-way guide support. For your two-way guide support, the support helps in keeping your object or your pipe so that you can have two ways in which you can move your pipe. Now from here we can see that it can be moved through the horizontal and also to the vertical. So that's what look at your two-way guide support. It has its horizontal and it was vertical. So we also have here talking about the properties. And remember that friction is along the pipe. Now, if friction is along the pipe, that's why it's been inclined at an angle that is not what limited. Okay, so the pipe is inclined at an angle that is not limited. So the properties in which you can change at any given point in time, depending on the requirements of your pipe and of the client that you are designing for. Okay, so this is one of these two-way guide support in START-PROF. This is the representation of two-way guide support in START-PROF. Okay, all right. So here we have the non-standard restraint. The non-standard restraint is a type of restraint that is used for flexibility, for the purpose of flexibility. So in this case now, it depends on where the pipe, that's the topography of the soil, where you are trying to install, or where that pipe is meant to be stored in. So if the pipe needs to be held at the top, you use this type of non-standard restraint, the first type here. So you have the first here, the second, all this variation shows you the non-standard restraint, mainly in areas where the topography of the soil isn't linear. So when you have such conditions, we mostly use this non-standard restraint in fixing our parameters so that it can stand the test of time according to design. Okay, then here you still have those properties that I told you previously. Okay, now the global coordinate system, just like we've talked about the Cartesian points before now, the global coordinate system has the X, Y, and Z axis in which your pipe is being modeled. Okay, now this global coordinate system is the way or the system that all your models look like. You have the pipe local coordinate system, and they also have the support local coordinate system. Okay, but mostly we use this global coordinate system in our representation. Okay. Now your elbow support, the dummy leg. Now for your elbow support, it talks about the support that is attached or affixed to your model when it has a bend. So if you watch this very well, to avoid leakage of fluid or materials, you see we need an elbow support. So if you watch very well, you will see an elbow support here. Elbow support helps in avoiding fluid and to enhance flexibility of your pipe. So this will help your pipe, that's the two pipes that are fixed to have balance, so that there will be no form of leakage or lag, that's leakage in between the pipes. Okay. So if this elbow support is not that your pipe or the model will wiggle, that it will have deformation. So to avoid such deformation, due to them, you need to affix your elbow. So this is the 3D of your elbow support. That's 3D representation of your elbow support. Your piping model having the elbow support, and this is the 2D representation of your piping model, the elbow support. Okay, so that's the difference between these two representation here. The first represents your piping model in 3D form, 2D format, having elbow support. Okay. Now here we have your dummy leg. So this is also of support that we use in keeping our piping model in place to avoid deformation, to avoid all forms of deformation as a result of bend. Okay. So here we have the variable spring support, then the sliding and rolling. So this is the variable spring support. So look at the different, these are all variable spring support. Okay. They are variable spring support. Then in START-PROF, it's like this. So in START-PROF, whenever you are variable spring support, so it's used, the variable spring support is used in keeping your model in place, in which you can, why it's called variable, you can increase the size or the length of the spring. Okay, so it has each fixtures that will allow for that. If you watch it very well, you see a bolt and a knot that is there, and also for this too, your variable spring to the level or to the extent at which you want it. So it's a variable spring support because there is a spring in that your support. So when the support has a spring, compresses and it's also tension. So if the load on the spring is much, it can compress. Then when that load is released, it's what? It will get back to its state. Okay. So that's why we call it the variable and reduce or increase the support. That's the length of such support. And when a load is affixed on your pipe, our time is up. Okay. So now we're going to be summarizing here. We're going to be summarizing our lecture here for today. So we all know from the review, from what we looked at today, we looked at different types of support, including the variable spring support. So let's look at this last slide. So we can end it. Now, this your last slide talks about your variable spring hanger. The previous one was the variable spring support. This is variable spring hanger. So for this spring hanger now, it's a hanger when the pipe or the model will be placed at the same at its center, and then it can still be adjusted. Okay, it can still be adjusted. So this is different. So you see, all what we've learned today are all built into this software to from its position and use it. And that's the beauty of START-PROF. Its beauty is that all these fixtures, including the formulas we've been seeing they are all software. It is very easy to use. We are going to call a and we'll continue subsequently. Thank you very much.